Okay, so some of you may already have written the inequalities for this one. I didn't post the key, I don't think. I posted the key for this one. So I guess just follow and see if you got it right. So here we go. Word problems with two or more inequalities. A bakery has two options for cake. Cake A requires 150 grams of flour, while cake B requires 75 grams of flour. No inequalities there just yet, right? It's just giving us a fact, right? How much each one of them needs. By the way, that could be, this time it's just grams of flour. It could be grams of sugar, grams of, like they could add more, raisins, whatever. Raisins and cake. Anyways, the bakery has 50 kilograms of flour available. I don't know if you see that, but the word available gives me an indication that like it's up to that much. That is, so I'm going to highlight that part. I'm going to get an inequality out of that one for sure. That's the first one we've identified. In order to profit, the bakery needs to produce at least 500 cakes combined. I don't know about you, but that is an inequality as well. At least 500 cakes combined. So that's IQ number 2. The bakery knows that cake A is most popular and therefore makes at least 100 of them. Okay, so this is specific to cake A, and they make at least 100 of them. Notice that it's specific to just cake A, so just one variable here. But that's IQ number 3. So we fished out using the keywords. We've determined, you know what, there's probably 3 inequalities here that we can tell. We're going to define our variables, state our implicit constraint right off the bat. I think it's safe to say here that X would be number of cakes A, and Y would be number of cakes B. It's probably worth noting that this is discrete data. Right? What does that tell us? We're going to have to round the points of intersections at the end. Okay, so, but I'd like to already tell myself that right off the bat so you don't forget. My next task is to state the implicit, so this is A, right? For B, state the implicit constraint. You can do this. So, sorry, X is greater than or equal to 0. You can do Y is greater than or equal to 0. Or you can just go X comma Y are both greater than or equal to 0. That's B. C, write the system of inequalities here. I want to use my space carefully, so I'm going to actually write the inequalities next to each other like this, so I can do the work right underneath them. Okay? So I'm going to be smart about the space that I'm given. So for C, this is, I guess, flour, the restriction on flour. And you have to do some conversion here. I will say that 50 kgs of flour, I want to turn that to grams. I don't know if you noticed that, right? The grams that each cake needs, right? That's in grams, so we have kilograms. So we're just going to say that 1 kg has 1,000 grams. Okay, cancel that out. So that's 50,000 grams available. And right, available, that's keyword for up to, has up to, the bakery has this much available. So here we go. Because we're talking grams of flour, we're going to go 150 grams for every cake A, 75 for every cake B, and that has to be less than or equal to 50,000, because if you surpass it, you're surpassing the amount of flour that you have available. So you have to make sure that the flour remains at 50,000 or less. That's IQ number 1. Am I going to run into trouble here? No, I think I'm good. Just going to break this a little bit. And then next we have, if you think of cakes produced, that's another restriction here. I'm just going to give it a heading here. And so that's just x plus y, the number of cakes that you're producing has to be at least 500 in order for you to actually make money. Okay. Obviously, you need to sell them then. And last is cake A produced. This is specific to just cake A. So cake A is X. So X has to be at least 100. So you've got all of that taken care of. So within these restrictions, we'll figure out what possible options the bakery has to choose from. But we're ultimately going to figure out the best solution. That's coming down the line next week. So let's work with these here. So same as before, I go x-intercept. By the way, my idea is to use, if you look up here, I want to use this corner here for my graph, more or less. So I'm going to try to keep that in line there. So x-intercept, y-intercept, probably used up a bit too much space, but we'll make it work. So we have 150x is equal to 50,000. Do you need to zoom into that? Sure, I will do that. There we go. And then just like before, we just divide by 150. You should be experts at this point. So 50,000 divided by 150 is 333.33. So you'll notice that they're bigger numbers now. And that's not a problem at all. We're just going to adjust accordingly. Then we have 75y is equal to 50,000. That's our y-intercept. And that is 666.67. So that's 0. There you go. Your intercepts, they're decimals. That's okay. We'll just plug them in somewhere on the graph and make it work. There you go. And then rewrite it. 75y is less than or equal to. The 150x comes over to this side. You change the sign immediately. Plus the 50,000 that's already there. And here's where it can get ugly, okay? But we're not gonna, I most likely just leave it as a fraction. Negative 150 divided by 75 is actually negative 2x. That's not a problem. Here's where the problem shows up, right? 50,000 divided by 75, we know 666 and repeat it. So I'm just gonna leave it like that. I'm not gonna, because I want to enter this into my calculator, and when I find the points of intersections, I want them to be as accurate as possible. So just leave it like that. Don't sweat it. You're just gonna put brackets around it when you enter it. Same as before, just bigger numbers maybe. So we know this you have to tell yourself here. Don't do this later because you're gonna be all confused, right? Solid. True region is where? If it's less than, we know that the true region is below. Therefore, I will shade above because I'm using reverse shading here. This is the ugliest inequality in this problem here. Doesn't look pretty, but we can make it work. Next, the easier ones. I will kind of block this off here. This one is actually fairly simple to do. The x-intercept, y-intercept. After a while, you're just gonna know already. But if y is equal to 0, x is equal to 500, so that's 500, 0. If x is equal to 0, you're just left with that, so that's 0, 500. So these are pretty sweet. When there's no, the coefficient is simply 1. Rewriting it is pretty sweet as well. The x comes over subtracting, so just negative x. Bingo, you're done. A lot less work. This is also solid. True is where. I encourage you to look at the one you've already worked with, right? The one you worked with is pointing the other direction. So true is below. Therefore, if this is pointing that way, true is above. They should be opposite, right? Since true is above the line, we're going to go ahead and shade below the line. We're doing the opposite. As I was writing the exam, I had to go talk to the French applied math teacher. I was like, oh, by the way, you ever use reverse shading? He's like, never heard of it. So I had to give him a little class on that. Okay, we're done here. One more. I hope you can see everything I'm doing here. So this one here is just vertical line. I guess the point you're after is this one. It's going to go through 100, 0. So this is solid. True is where? If it's greater than, I hope your study sheets tell you this. True is to the right. Okay, this is a vertical line. So true is right. Shade left. That's the one we're going to focus on, the shading. I'm going to circle all my shading. And now I'm starting my graph. Once you've done all of that, graphing time. Except for it's a word problem, we're sticking to quadrant 1. We can't have negative cakes, right? So here we go. Let's do this before the power goes out. You'd be super sad if that happens, right? Down here. And here, so I just make it work, right? My scale is gonna just have to fit the space I have. So this would be number of cakes A, and this would be number of cakes B. Just make sure it jives with what you let X and Y be at the top. And I look at my X and Y intercepts. Look at your X-intercepts. The biggest X-intercept is 500, right? So you got to make sure your Y-axis allows for that. Let me see here. I'm going to try 100, 200, 300, 400, 500. I'm going to go to 600 just for good measure there. So 200, 400, 600. That's what I did. Yeah. And what's the biggest Y-intercept? 0, 666, right, is the biggest one. So I gotta make sure that I have 700. Yeah. Oh, sure. Is that better? I'm going to use the same amount, but just make sure the 700 fits in. Let me see here. 1, 2, 3, 4, 5, 6. It just fits. So you might have to increase your 700 is up here. Usually the rain just waits until it's time to leave class, right? It doesn't rain until the bell goes and it's a... All right, you've got a nice scale. Everything will fit one at a time. So 333, this is 300. And at about a third of the way, right? This would be 350. So 333 is right about there. You match it with 666. This would be 650. 666 is right about there. Let's go ahead and graph. Don't shade just yet. And I'm going to use my original version of my inequality to label that one. 500, 0, 0, 500. My next line. That's that one. And the last one is, it goes through 100. It goes through 100 right here. So just make a vertical line. This is x is greater than or equal to 100. Looks pretty, doesn't it? Just wait till we add the shading. We're good for the shading now? All right, so one at a time. I go with my first line, okay? My first line I know is this one. And you told yourself that you're going to shade above. I don't know if you can see it just beside there. Okay? Shade above. So let's go ahead and do that lightly. I'm saying lightly because sometimes we do make mistakes and then you need to erase the whole thing. And if you went to town, it's going to be a very big smudge fest, okay? So there's my first. So that's all false. It doesn't work. Then you go with the other one. It's my second line right here. I told myself I'm going to shade below on that one, correct? So I got to go and shade out all of that. So that's basically saying all of that doesn't work for the system. Okay, that's when I like reverse shading. You're saying, hey, that it doesn't work for this one. It will not work for all of them. Okay, it doesn't work for the system. And last but not least, the vertical we're shading left. Okay, so this is where you have to be careful. If you told yourself shade right, this would be your solution region. But if you did this correctly, you should have to shade the left of that vertical. So that just gets rid of that little wedge there. So you have to tell me the solution region. It's that little triangle there. So as best as you can, you write in that is the solution region. Only options that are inside that region will work and make sure all the restrictions are met. Okay? So now we're going to figure out the corner points. These ones here. These are surrounding. Remember, it's always surrounding the solution region. Those are the POIs. I'm going to do that beside, okay, on the side somewhere. Because right now we're telling the audience these are all possible solutions, right? These are all possible. We're going to narrow it down. Let's do F before we do E. So F, graph these. So can you enter these into your calculator? I'm actually going to let you do this yourselves first, because this is something students struggle with, and it's just a matter of practice. So I want you to enter all of the equations into your Y1, 2, 3. You remember how to do the vertical line? If you don't have that on your study sheet, you're going to forget on the exam. So make sure you have the 999, right? 9 nines. I'll let you figure it out. You have your notes. I'll pause here for a bit. You find those 3 POIs that I'm after. Well, I entered them all. Make sure plot 1, 2, 3 are off when you're not doing a regression, okay? Because sometimes it does give you a conflict there. I entered everything. Notice how I entered the y-intercept of the first one in brackets. And then the vertical line is simply x, the opposite sign of what you have here. Right? You graph it. I used the window based on what I had here, right? I went y max to like 700, x max to 600. I changed all those things, and then now I see what I need to see. So second trace 5. If you're on the blue line, you hit enter. I'm already on the red, so it's going to find me this intersection. So that's 166, 67, 333, 33. That's one of them. Okay. We're going to have to round that one, but for now, we'll just keep going. Second trace 5. You're on the blue line again. I'm going to jump to the black line. So you know you're on the black line when everything turns black, right? Enter, enter, enter. And so there it is, 100. 466, 67 is the next one. One more time, second trace 5. I'm going to jump to the red one. Hit enter. It automatically jumps to the black one. So you want the intersection between those two, and it's 100, 400. There you go. There are other ways of doing this by turning off the one you don't want and just keeping the 2 you do want to see on there. You got to go to y equals and just deselect the equal sign, right? Unselect, deselect, I don't know, right? So if you're like, I just want to find where these two meet, you hit graph, and then you don't have all that busyness there of the other ones. Hit the equal sign again. There you go. Okay. So we can't have this, so we're going to round. This is 100. We go 467. I just always tell you to round up. Just round up. Or to the nearest, sorry, I should say to the nearest whole number. So this would be 167, 333. There you have it. Okay? And we do this because it's discrete. You can't make partial cakes, right? I mean, you get fired if you take a bite off of the cake you make, right? But there we go. Make sure you round when it's, but I want to see both of them. Okay, I want to see that that you actually calculated them, and then you round as needed. Okay. E, state a possible solution. Anything in here. So we can try. We can see 110. I'll just pick one of these. 100, 400. Baking 100 of cake A and 400 of cake B is a solution. Sorry, I'm going to zoom into that. I know I kind of ran out of space, but this is E right here. I need to start writing a little smaller or giving more space on the page. So there you have it. Sure, you could have picked something in the white region, but it might be a bit tricky. So just pick one of the corner points. Since all lines are solid, it works. Okay. All right. I'm going to stop here and I'm going to ask you to go to town and try the next ones on your own. 50. I would say 50 to 54, basically. That's where it ends. Okay. I would say do at least two major ones like these. And you may see a pattern. I'm not going to say what it is, but you may find out, oh, wait a minute, this one looks familiar. And that's okay. I'll just show you here real quick. I will post the key where I work through the whole thing, but pages 55 and 56 actually have printouts of what the graph should look like. Okay, so these are the answers to those, to the what the graph would look like ultimately. Okay, so 50 to 54. Let me just check here. Yeah, the other ones, I'm just going to leave the other ones. So if you can get at least one done today or get started, that would be great.